I'm in the process of shooting a repair video, and as part of the process I needed to test a transistor. So I got out my Tektronix 577 curve tracer, fitted the transistor I wanted to test into the fixture. This is the replacement transistor. I'll need to test the transistor that comes out of the unit separately. So I fitted this into the curve tracer, switched on the curve tracer. I'll just dim the light so you can see the screen of the curve tracer a bit better. Wait for it to warm up. And I realised that the curve tracer isn't working. So it doesn't matter what I do, this is all I get. A little bit of variation on the position of the dot, but other than that, nothing whatsoever. So this worked a few months ago when I put it away, but clearly it's not working now. Let's turn the light back on. So rather than just fixing it and not showing it, I thought it might make an interesting repair video to try and figure out what's wrong with this. Hopefully it'll just be a single video, but really it depends on how complex the repair gets. So thinking about this and knowing what's inside this, quite often you can do some of the repair diagnostics before you ever open a unit up. So thinking about what the unit's doing and the nature of the circuits in here, then what I suspect is wrong with this is either one of the power rails has failed. Bear in mind this is very much an analog machine, there is no processor in this. So for example, the step ramp generator is just really an op-amp with a capacitor used as the feedback loop, and it's just fed a series of pulses, and that creates the step waveform that's used for the step analysis. So it's all analog, and that means that when we get a fault like this, most likely it's a problem with the power supply, or in this case I suspect it's a failed tantalum capacitor. Notorious tantalums for failing and going short in machines of this era. It could be a failed regulator, but because it worked fine when I put it away and there was no kind of smells or anything when I turned it back on, it just didn't work. That's the kind of how tantalums tend to fail. They tend to go short when the unit's not in use. Having said that, it could be a faulty connector, could be a blown fuse, could be anything like that. So what I'll do is we'll get the covers off, we'll open up the back so we can see the power supply board, and we'll go from there. I'll test all the rails, see if we can find a starting point for a repair. So I took the 4 screws out that hold this in place, flipped the board down, and I started testing the rails, and sure enough the plus 12 volt rail was reading 0. So I've turned the unit off, and I then measured for any short circuits between the rail and ground, so either the regulator's failed or something's pulling it down. So the easiest check with the power off, bear in mind the voltage was 0, is we'll do a check between ground and the 12 volt rail. And you can see we're getting 7 ohms, which is obviously not correct. It shouldn't be that low. So I took out the regulator to see if it was that was short circuit, but as you can see the short is still present, so it's not the regulator. So it looks like we have a short somewhere on one of the boards. So the next thing I'm going to do, and all the fuses by the way are intact, there's nothing wrong with those, but like I said, we've got a short somewhere. So the next thing to do is figure out where in the machine the short is. The 12 volt supply goes to numerous locations. So the easiest way to do this is we'll unplug the connectors at the left hand side here one at a time, and we'll see which one hopefully clears the fault. It could be something on this board itself, but it's unlikely. The 12 volt really just goes straight out of this board, and because it's a complete short, it's unlikely to be a electrolytic or something like that, again partly because of the way the unit failed. So we'll start unplugging these and see which one we have to unplug before the short hopefully goes away. So first one's off. Let's see if that's made any difference. We might get some small variations, but really we should see the short disappear. So it's still there. Put that one back on and take off the next one. So that's the next one taken off. There's only 3 on here, so it shouldn't take too long to hopefully find the culprit. So we'll try this one. Okay, we're now getting 2.7K, so it looks like the short is indeed on this lead. I'll put it back on and make sure that it isn't something else and we've just disturbed the short. So I'll reconnect this. I've refitted the connector, so we'll check to see if the short has returned, and hopefully it has. So as you can see, the short is back. So the next thing is to figure out where that particular lead goes to. And just, you can't see, it's a bit dark in there, but trying to find out where the lead goes. And it goes through into this left hand side of the machine. So what I'll do is take off the left hand cover. We'll have a peek in there and see if we can figure out what's going on. So one of the nice things with these machines, this type of equipment, is how easy it is to access the inner workings. In the case of the side covers, there are just 4 of these quarter turn connectors. I've backed off the 2 left hand ones. We'll just undo the 2 right hand ones, and then we should be able to remove this cover. That's out of the way. Okay, I'll just lower the light a bit so hopefully we can see what's going on in there. And the connector we're interested in, just trying to see where the lead goes, is this red one. So it's red, not colour coded, it's red at either end. So we'll get the yellow one out of the way. Okay, and see if we can find which particular pin we are interested in. So I've got the ground lead of the meter connected to the plus 12 volt test point on the power supply. So one of these pins should be connected directly to it. Okay, so it's that one. I'll now move the ground lead of the meter to ground, and we'll see if we're grounded at this end as well. And clearly we are, so 12 volt rail is indeed shorted to ground somewhere. Now I suspect, as I said, that the main culprit here is going to be one of these tantalum capacitors. The nature of the way this has failed, it seems to have failed when no power has been applied, and that is the way that tantalums seem to fail. They just develop short circuits as they sit around doing nothing. There are quite a few on here. Now I have printed off the schematic for all the boards. Just find the one for this particular board. Okay, so it's this one, and it doesn't really seem to show many of the decoupling capacitors. It's only showing one on a 12 volt rail, so that's not going to help us very much. Now what you can do in a situation like this, if it's a vintage computer, then you'd need to be very careful. If you run it without all the rails present, you can destroy DRAM devices and that sort of thing. And what I'm going to do, again, I'm going to put one lead of the test meter to ground, and then we can start trying to trace where the particular lead goes. So it goes to that one, but I suspect it goes to quite a few of these capacitors. The entire board is really a series of op amps, and each of those op amps is going to have a decoupling cap. So there's, having a quick look, there's about 20 tantalum capacitors, and it could be any one of them. I don't want to really have to take the board out and start fault finding. It's a real pain to get the board out of this. So what I'm going to do is a different technique, and what I'm going to do is something that you can try with a machine like this, but I definitely would not do this with a vintage computer, but because this is completely analog and it doesn't really matter if all the power rails are present, you can power the rails one at a time. You need to be fairly careful how you do it. You don't want to overvolt or overcurrent it, but what I'm going to do is apply some power, low voltage, fairly high current, to the 12 volt rail. We know it's a dead short. In fact, it's not a dead short. There is some resistance there. There's about 7 ohms, and that again is how tantalums tend to fail. So they will have a bit of resistance, and because they've got a bit of resistance rather than a dead short, they will dissipate power if you supply current to them. Don't want to supply too much. I don't want it blowing up and damaging the board, but if we do that, then we should see one of the tantalums, and maybe more than one, there could be more than one with a short, but the suspect devices should start to get warm. They might not get particularly hot if we don't supply too much power. We'll keep the power fairly minimal, maybe half a watt, something like that. So we can of course use the thermal camera to try and identify the suspect device or devices. This will pick up just a few fractions of a tenth of a degree, so we don't need to put a lot of heat and energy into the devices and risk blowing up or damaging the board. The machine will be turned off. There won't be any power going to it other than feeding power directly to the 12 volt rail, and we'll do that from the bench supply. So what I'm going to do is clip a lead to ground on the power supply board back here, the other lead, the positive lead, to the plus 12 volt test point, and then we'll point the thermal camera at this board and see if we can see if any devices are warming up. So I'll get that set up. So I've got the bench supply set to 2 volts at 0.5 amps. It's connected between ground and the plus 12 volt test point. Remember, the regulator, the 12 volt regulator, has been removed. So all we're going to do now is feed 2 volts to the 12 volt rail. That won't harm anything, and we'll then point the thermal camera at the board and see if we can figure out which of the tantalums, if that's what it is. It could be a device, but seems unlikely. Most likely it's a tantalum cat, but we'll find out in a few minutes. Now it's not yet powered up, but notice there are some apparent hotspots already. They're not hotspots, that's just because they're reflective surfaces, and what we're seeing is really a reflection of the warmth of the room in the camera. So what we're looking is for something to change. Have a quick look first. There's nothing particularly hot in here. So I'll turn the bench supply on. We'll see if there's any current drawn on the supply. There should be, because it's feeding into a dead short. So yes, it's drawing about 300 milliamps at 2 volts, and we'll have a look and see if anything is getting warm on the board. Nothing showing up so far. Possible suspect down there. Something there as well. I think that again is just a reflection. The camera's gone into standby. Switch it back on. So we've got something possibly down here that wasn't there before. I don't think that's a reflection. Nothing's really standing out just yet. So I'm going to up the current a little bit on the bench supply. We'll go up to 0.5 amps. As I said, we're only putting a couple of volts into the board, so nothing particularly horrendous. We'll get up to 3 volts. Okay, so yeah, if we look on the thermal camera now, we can see something definitely in that corner. There's nothing anywhere else, so let's just see. I'm just going to try and figure out what we're actually looking at here. I'm just going to put my finger in the area. It's not as hot as it looks, by the way. And sure enough, where the hot spot is, there's a tantalum capacitor right down here in this corner. Feels, yeah, it's getting warm, so that's definitely warming up. It's not hot, but it's definitely warmer than it was. So hopefully you can see on the thermal camera we're getting it's up to around 25 degrees, 26 degrees, 28, but definitely warming up. So what I'm going to do now is turn the power off on the bench supply and see if that goes away, just make sure it's not a reflection. Take a few seconds to cool down, but as I said, if there's a reflective surface, then that can give us some kind of false reading of a hotspot. So I'll turn the supply off and we'll see if that hotspot goes away. Just keep checking the rest of the board to make sure nothing else is showing up. Turn the camera back on again. It is cooling down. It's down to 23 degrees. Like I said, the camera, it is kind of deceptive when the whole thing's the same temperature. You get areas that look like they're incredibly hot, but it's only a few degrees, which is why it takes a long time to cool down. But hopefully you can see that area is going away. So I'm going to give it 3 or 4 minutes, let it cool down completely, and then we'll turn it back on and see if that reappears. So it's had a few minutes, and sure enough the hotspot has more or less completely disappeared now. Like I said, the residual heat will stay there for quite a long time. We're talking here about less than 1/10 of a degree. What I'm going to do now is turn the bench supply back on and we'll see if that hotspot reappears. And sure enough, it has come back. So it looks like that is the faulty device down in this bottom corner. The bench supply is set to 3 volts and it's currently supplying about 150 milliamps. So what I'm going to do is just snip off one lead of that device and we'll see if that allows the short to disappear and the rail to come back up. Don't forget the regulator's not there. I don't want to power it up to the full 12 volts from the bench supply with the rest of it shut down. Shouldn't do any harm, but I don't want to risk it. I just want to see if we can get rid of the short. So I'll just snip one of the leads off. So I've snipped one of the leads off the device. We'll power the bench supply back up and see if the current has gone down. And yes, the current has now dropped. It's now just 70 milliamps. So that seems fairly reasonable. And what we'll now do is refit the regulator and see if we get the full 12 volts when we try powering this up from the mains. So I'll get this partly reassembled. I'll leave the covers off and I'll reconnect this connector and then we'll try powering it up and see if we're getting any nearer to a repair. Okay, I've replaced the capacitor. I was able to snip out the old one and solder a replacement in without having to remove the board, which is fortunate. As I said, the board is a bit of a pain to remove. I've refitted the regulator, and what we'll do now is just recheck the supply rails, and if they're okay, we'll button this back up and see if it actually now works. So we'll get it switched on. No magic smoke has escaped, which is a good sign. So we'll test the supply rails. Got to be fairly careful, some fairly high voltages in here. Just making sure I'm not blocking the view of the meter. So there should be 30 volts. The voltages are written on the board, by the way, so that's 30. Minus 30. 200. Minus 12, and finally our plus 12, which is the one that was missing. So yes, all present and correct. Can't see the screen from here, but we'll assume it's working. I'll refit the board, refit the cover on the side, and we'll take a look at the front and see if we fixed the problem. So I've reassembled the unit, put the cover on, put the power supply back in, and we'll try powering this up and see if we've improved things. I must dim the lights a bit so you can see the screen a bit more clearly. Move this one back out of the way. Okay, so we'll select our device. I've got the transistor fitted to the fixture and it should be set up for a decent curve. It was, I did have it set up when I was trying to test it before, but it wasn't working, and now clearly you can see we're back up and running. So that's a successful repair. Usual tantalum capacitor issue, just a single shorted capacitor, and that's all it takes to kill a machine like this. And we're now working. I can carry on with the repair I originally started on this morning.